two specific pieces of technology we're using on this trial are part of demand-side response at the domestic or customer level. So we're calling them smart grid-ready technologies, things like the smart washing machine and smart heat pump. And the reason we call them smart technologies is because they can actually be used interactively with the grid system to manage demand, especially in periods of peak demand. So an example of that is our smart heat pump. So what this does is it uses a large tank of water which it heats up to provide the main source of heating and hot water for the house. The heat pump is still using electricity, but if there were an issue with the grid where we needed to reduce overall electrical demand, we could send a signal to that heat pump which would reduce its consumption down to almost zero. However, the householder's supply would still be run from their heating and their hot water from this tank of hot water, so they wouldn't really notice any effect on them, but the overall electrical consumption and therefore the stress on the grid would be reduced.
Air source heat pumps are a developing technology mainly applied for off-gas communities, and what we find is that off-gas communities really do struggle at the moment with their fuel bills. A lot of them are using oil and liquid petroleum gas to heat their homes, so air source heat pumps can prove to be quite a good solution. Now what you do find though in these kind of off-gas areas is that the grid is a little bit more, let's say, fragile. So in order to install large-scale clustered air source heat pumps, let's say 30 in a given area, you would have to actually put in network reinforcements.
I think with the new heating systems there was a bit of a learning curve for customers. It's quite different to the heat system they had before, so we had to make sure that we had the education that went with it so customers understood what the new heating system was, how it worked, and so they were comfortable using that from the start. And we've had a really low dropout rate on the trials, less than 2%, so customers overall seem to be pretty happy and we're getting good feedback, so seems to be working. So
it was really to kind of understand to what degree of network reinforcement was required and also how people actually use the air source heat pumps. So from a fuel poverty point of view, really important for us that we understand people making the transition from oil or LPG to use an air source heat pump. What does that mean for them in their homes?
We've been looking at energy efficient systems for a couple of years. I contacted British Gas to ask them what sort of things that they did and how it worked, and they said about the nano system, they said that would meet my requirements. It's an air-to-air source heat pump being monitored by Durham University. They're taking all the information via the internet, so we don't physically have to do anything, they just source all the information from that. It's very rural around here. The weather temperatures really drop rapidly, and where the old system we used to have it on a timer, so it would come on of a morning, it would go off. If we were here during the day and it turned cold, we would have it on during the day and then of an evening. But the system on this one, it will be a nice constant temperature so that it's not going up and down all the time. We're not getting younger, so as old age pensioners it appeals to us, and at the end of the day our pocket will be a little bit better for it.